In this problem, we're going to use Descartes' rule of signs to find the number of positive and negative real zeros. Let's start with the number of positive real zeros. So for the number of positive real zeros, you start by looking at the sign changes. So look here, we have plus, 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 plus. So there's no sign changes in f of x. So there's no positive real zeros. So nothing to do here. We only need sign changes. Okay, let's look for the negative real zeros. So for the negative real zeros, what we do is we have to replace x with negative x. So let's rewrite it as f of negative x equals, and this becomes negative x cubed plus 2 times negative x squared plus 5 times negative x plus 4. Okay, so this is f of negative x. So because it's odd here, the 3, it's going to stay negative. So this is negative x cubed. And then here, this becomes positive because it's being squared. So plus 2x squared. And then here it's minus 5x. And then plus 4. Okay, so now we're going to count sign changes. So to count sign changes, you just count sign changes. So we have 1 here because it goes from negative to positive. We have 1 here because it goes from positive to negative. And we have 1 here because it goes from negative to positive. So we have 3 sign changes. And so what you do now is, now you know, because you have 3 sign changes, you have the following. You either have 3 negative real zeros, because we have 3 sign changes, or, and then you just subtract an even number. So in this case, 2 is the only even number. We can't subtract 4 because it'll put us at a negative. So 3 minus 2 equals 1 negative real zero. So you always just, pretty much on these problems, you always just subtract 2. So we have 3 or 1. So we have 3 or 1 negative real zeros by Descartes' rule of signs. If we had sign changes for f of x, it'd be the same thing. You do the same thing. You just count the sign changes, and that's how many you have, or that many minus an even number. I hope this video has been helpful.